Right. Next up, we're going to talk about the heat of reaction. So chemical reactions involve matter, but they also involve energy. Call it capital E for energy. And generally what we're going to be talking about here is either a release or an absorption of thermal energy, which we're going to call heat. So release or absorb heat. And then we're going to give this a fancy symbol. We're going to call this delta, which is just a big triangle, and then a capital H. So delta H. Delta H is going to be known as enthalpy. And for our purposes, it's just going to be the amount of heat released or absorbed in a reaction, right? So it's just the amount of energy that we're just going to call heat absorbed or released during the reaction, and gets this fancy symbol of delta H, which is going to be our enthalpy. It's going to have units generally of kilojoules, sometimes just joules, but usually kilojoules. This J stands for joules. And it's just a unit of energy. Oops. One that you may be more familiar is a calorie, right? You see calories on your food and whatnot. So 1 calorie is equal to 4.184 kilojoules. The capital C calorie, right? So, you eat a donut, maybe that's like 200-300 calories. That would be a whole bunch of kilojoules of energy. So again, like what we said, you can either release or absorb this heat, and we're going to give these fancy names as well. So we can have what are known as exothermic reactions. And exothermic reactions release heat. So the reaction itself is going to lose energy and it's going to release it to the surroundings. And since you're part of that surroundings, you're going to feel that heat. And so an exothermic reaction will feel warm. An example of an exothermic reaction are fire/combustion reactions. Right, they feel warm. That fire is releasing its energy, and then you're feeling that in the form of heat. What we say with exothermic reactions is they have a negative delta H, right? Because we're talking about the reaction and it's losing heat or it's losing energy. So we have this negative delta H. And in Chem 101, you'll learn more about reaction coordinate diagrams, but let's just draw this little graph. H will be on the axis right here, and then the reaction coordinate will be on the bottom. And then we're going to have our products A up here and then B down here. And this is an exothermic reaction because you can see that B is lower in energy than A. And so when you go from A to B, you're going to release that energy. Like when you drop a ball, that ball releases its energy to the atmosphere in the form of friction. Heat released, right? And so our delta H here is equal to some negative value. You'll learn a lot more about this in Chem 101 and 102. And then the opposite of that, we have endothermic reactions. These absorb heat. And they're going to feel cold. They're feeling cold because the heat from your hand or the energy from your hand is going into that reaction because it's absorbing it. And so you're losing that energy, and so it feels cold. Example of these are those like chemical cold packs. Not the ones that you put in your freezer, but like the ones with that little separator, and then you crush it open and then it gets cold. Basically, you have two reagents there. They mix, there's an endothermic reaction occur, and so it absorbs all that energy. Obviously, that's the opposite of exothermic. So here we're going to have a positive delta H. And then we can draw our little reaction coordinate diagram in the opposite way, right? A will be down here, and then B will be up here. And what we can see is we have an absorption of energy. So heat absorbed, delta H is going to be some positive value. So let's just take a look at some examples of some reactions and how we're going to write our enthalpy of reactions. So here we have C3H8 plus 5O2 going to 3CO2 plus 4H2O. The C3H8 is propane. So, and you can tell this is a combustion reaction, right? Combining with oxygen to form carbon dioxide and water. So this is what happens when you fire up your grill, right? They're usually attached to propane tanks. And so you burn this propane, and think about what a grill is. It's warm, which means that it's exothermic, which means our delta H should be negative, and indeed is, right? So this delta H here is equal to negative 2044 kilojoules, right? You can see it's negative, and so this is exothermic. And we'll talk about how to deal with this number in the next section. If you can have endothermic reactions as well. So for example, if you have nitrogen and oxygen, they can actually combine to form nitrogen monoxide. And the delta H here is going to be a positive value. And so since it's a positive value, we know that this is endothermic. So this top reaction here is exothermic. It's releasing heat. It's going to feel warm, right? Burning your propane grill. The bottom reaction is endothermic. It's absorbing heat. It's going to feel cold.